Good morning, students. As we have already discussed the different rules of ray diagrams, or the rules that we use for ray diagrams, so here we will be doing the six ray diagrams of concave mirror. So in concave mirror we have generally 6 ray diagrams that are very much important for the exam point of view, and here we will see how these 6 ray diagrams are done and how we can do these very easily. So the first one we will see here. You see the first one. Here the object location, the location of the object, we place the object at infinity. Means we do not know where the object is. It is at infinity, somewhere very long distance. So from that one, the light will come parallel to the principal axis. So here we know this is the principal axis. In the first video we have already discussed the different parts of a mirror, and the light ray from that one will come straight or parallel to the principal axis, because we know that the light ray travels always in a straight line or in a straight line. So the light ray will travel parallel to the principal axis, and after hitting to this mirror, this is a concave mirror, this side is, this left hand side is a reflecting surface. So after hitting the light here, the light ray will move towards the focus or to the principal focus. As we know, this is the first rule of that ray diagram, that when the light ray moves parallel to the principal axis, after reflection the light moves to the principal focus. So similarly another light ray will come, because the object is at infinity, so light ray cannot come through other points. Light ray will always come straight, or it will always be parallel to the principal axis. After reflection it will go through the focus. And we need to remember that when two reflected rays are intersect, then at that point the image is formed always. So here you see I have used 2 different pens in different color. One was black and another was blue. So these black ones I have marked with this arrow. So the black ones are incident ray. These 2 black ones are incident rays, and these 2 blue ones are reflected rays. So after reflection these rays are moving to the focus, principal focus. So they are meeting at this point. These 2 reflected rays are meeting at this point, you see here. So at this point the image will be formed. So now we see object location. The object is at infinity. Image is located where 2 these reflected rays are meeting. So they are meeting at this point at principal focus. So we'll write image location is at focus, or we can write at F only. And what will be the size of the image? So here you see the size of the image is like a very small pointed. So here you will write highly diminished, or HD we can write, or point size we can write, no problem. And what is the nature of the image? So in class 8 also we discussed the nature, that is real and virtual. There are 2 different types of images we can obtain. So this is a real. So you see the images that are formed in front of the mirror are known as real image, and real is always inverted. You remember, real is always inverted. In other case you can see that here you cannot see because it's a very pointed size. Here we cannot see whether it is real or inverted, but if it is a real image, it will always be an inverted image. Okay, so this is for case 1, and now we will move to this second one. So second one is, now we will bring the object little closer towards a mirror. First we place the object at infinity. Now we are bringing close the object towards the focus. Now here we brought the object beyond C. Here we have the center of curvature. So beyond that one we placed this object, and we gave the name of the object as A and B. So it's a object, and the top of the object is named as A, and the down one is named as B. So it is the object AB. And similarly here from this point, the one light ray will move straight parallel to the principal axis, and after reflection it will go to the principal focus. As we know, this is the rule 1. And another rule, so here you see this, the light ray is moving towards the focus, and after reflection it will be parallel to the principal axis. This is the second rule, as we know. So to draw a ray diagram we need to apply any 2 rules. So here we have applied 2 rules. The rule 1, the rule which states that if a light ray moves parallel to the principal axis, after reflection it will move to the principal focus, and if a light ray moves to the center to the principal focus, after reflection it will be parallel to the principal axis. So here you see both these blue lines, these are reflected rays, are meeting at this point. So here the image will be formed, and here we will draw the image, and you see this is the image. So this one will be the head of the image and this will be the down or feet or down of the image. So it will be marked as A dash and B dash. So here we will see where the object was located. So the location of the object location is beyond C. So beyond C, and image location is between C and F. Between center of curvature and principal focus, the image is formed. And size of the image, you see, in compared to this object, the size of the image is little smaller. We can write this diminished, we can write small also, no problem. And what is the nature of the image? So you see it is in front of the mirror, so it is real, and it is upside down, so it is inverted. Okay. So next we'll jump to the third case. Here we are, as I have already told, that we are bringing the object closer to the mirror or closer towards the mirror. So we will bring the object at the center of curvature here, as we are bringing it close. So we will place the object at center of curvature, and similarly we will apply any two rule. The first rule states that if light ray moves parallel to the principal axis, after reflection it will move through principal focus, and the second rule states that if light ray moves to central principal focus, after reflection it will be parallel to the principal axis. So here these two blue lines are reflected rays and these two black ones are incident rays. So these blue or incident rays are meeting, these reflected rays are meeting at this point. So here if we extend the line, this will be our image. So object was at A and B, and the image is A dash and B dash. Okay. So the object location is at C, at center of curvature. The image is also found here. You will see one very interesting thing. When we place the object at center of curvature, the image is also formed at center of curvature. This one is very important. From this ray diagram, one multiple choice question is asked in the exams many times. So you remember this one. When the object is placed at center of curvature, the image is also formed at the center of curvature. And what is the size of the image or image size? So here you see the size of the image will also be the same as of the object. So if the object is 10 centimeter, the image will also be 10 centimeter. And what is the nature of the image? It is also real and inverted, because it is formed in front of the mirror and you see the image is inverted. Okay. Next we will move to the fourth case. As I told, the object we are bringing close. So now we will move it little further towards the mirror, and here we will place the object between C and F, or between center of curvature and principal focus. So we will give the name of the object as A and B, and we will apply rules. The first rule, the parallel, after reflection it will move through principal focus. The second rule, through the principal focus, after reflection it will be parallel to the principal axis. And these two reflected blue lines, that is reflected rays, are meeting at this point, and we will extend this and we will get the image. It is A dash and B dash. So where the object was located? Object was located between C and F. And what is the location of the image? Beyond C, or beyond C the image is formed. And what is the size of the image? It is, in compared to this one, it is little larger. And what is the real nature of the image? It is also real and inverted, because it is in front of the mirror and it is upside down or inverted. Next we will move to the fifth case, where we will place the object at focus. Previously we placed between C and F, now we will place it at F. And what is the location of the image? Here if we apply two different rules, we find that the image is forming at some point. These two lines are moving in such a way that they will meet at some point, but we do not know where it will meet. So we will write it at infinity. The image will form at infinity. The two light rays will meet at infinity. And what is the size of the image? It will be a very large or very big and large image. In compared to this object, it will be a very large image. So we will write highly enlarged. What is the nature? It is also real and inverted, because it will form in front of the mirror, and it is also upside down. That's why it is real and inverted. Now we will move to the last case, that is sixth case. As we are bringing the object closer towards the mirror, here we will place it between principal focus and the pole, or between the mirror. So between principal focus and between mirror, we will place the object. We will name it A and B, and we will apply two different rules. This rule one, the light ray which is going straight or parallel to the principal axis, after reflection it will move through principal focus. And the second rule we will apply here, that is fourth rule. We know that when a light ray falls on pole obliquely or slantingly, and it will pass, or it will reflect in such a way that these two angles will be always equal. So this is the fourth rule, we know that. So here after reflection it will move through, or it will go to in this way. So these two blue lines are reflected rays. After reflection, these two lines are going, and here you see one interesting thing. These two light rays or reflected rays will never meet because they are moving in wide way, so they will never meet. So we have to extend in such case we have to extend the light rays backward. So if we extend the light rays backwards, we find that these two reflected rays are meeting at this point. So if we extend the line, we find that the image is formed behind the mirror. It is A dash and B dash. So here the object location is between F and P, and where the image is formed behind the mirror. And image size is enlarged. We can write highly enlarged, no problem. With either we can write enlarged or we can write highly enlarged, no problem. Then image nature of the image will be virtual and erect. You see, in front of the mirror is real and behind the mirror is virtual and it is erect. Here you see the object is erect. A dash and B dash, it is like this object is erect. So these are the 6 different ray diagrams of concave mirror. And in convex mirror we have different ray diagrams that will be done in the next videos. And here you see one very interesting thing. When we bring the object closer to the mirror, the image moves further. So here you see, here you can see the object was further away, or at infinity the image formed at focus. When we brought the object towards the mirror, the object moved from this principal focus, it moved little this side. And again when we brought the object at center of curvature, the image moved this way, little that side. And when we brought it again here, the object moved, the image moved this way. So when you bring the object towards, bring close towards the mirror, the image moves further away from the mirror. So this is very interesting thing you need to remember. So these are the 6 different ray diagrams that are very easy. I will suggest you to practice these ones. Give it a try, and if you find any kind of difficulties or anything, you just ask me. And remember one thing, you always do it with the help of ruler or scale, because without those things you will not get the correct or accurate measurement or position of the image. So image location will not be accurate if you do not do with the help of a ruler or with the help of measurement. So you first you give this, or you make with the help of this compass. With the help of compass you make. I will show you how to make it. So with the help of this compass, you will place the compass here at center, where you first give one line, and here you place the compass and you make one concave mirror. So you can make the convex also like that, convex also, no problem. So with the help of this one you will make the concave mirror, and then you will give this non-reflecting surface with the help of this pencil, and you give this point where you place the this sharp side of the compass, you give the center of curvature, and from here to here you measure. So if this length is 10 cm, you give at 5 cm one point, and that will be our focus, because we know that the radius of curvature is the double of the this focal length. So you give the focus here exactly at the half of this length. So if it is 20 cm, you give it here at 10 cm. If it is 8 cm, give it at 4 cm one point. That is focus or principal focus. And then you mark them as C and F, and then you place the objects. And here you give this as F, you can this P you can easily give. And this is the name of the mirror, that is M and N, M and N. Okay. And one more important thing, you always need to give these arrows. Without these arrows, your diagrams will not be correct, because this arrow shows whether it is an incident ray or reflected ray. Okay. So I hope you understood. If you have any kind of confusion or any doubt, you can ask me. And thank you for watching the video.